Now, there are multiple ways of doing nearly every problem. You have to make sure you are showing work. Are there any obvious identities that jump out right away?
Tangent over, oh no.
Nope. Yes. So nothing obvious. So let's go to sines and cosines. If I don't see anything else, I do that. What is secant?
1 over cosine.
And remember, the reciprocals, that's what you need to know without a formula sheet. Cosine, we can't do anything to. That's the same as just cosine over 1. Tangent, if I'm changing to sines and cosines, that would be sine over cosine. Cotangent would be, if I want to divide fractions, we flip and multiply. Okay, so this would be sine x over cosine x times sine x over cosine x. If you multiply the first ones, what do we get? 1 over cosine squared x. Multiply these, sine x times sine x would be sine squared x over cosine squared x. Everyone with me? What could I do from here? Really, 2 different ways of you could put it in one big fraction if you wanted. What is 1 minus sine squared?
Cosine squared.
From that first Pythagorean identity. And cosine squared x divided by cosine squared x is 1. There are other ways. If you had went to this point, 1 over cosine is secant. Sine over cosine is tangent. And look at your Pythagorean identities. You have a tangent squared plus 1 equals secant squared. So if you subtract it over the tangent, secant squared minus tangent squared is also 1. So different ways you could get there.
I didn't like tangent, 1 over tangent.
And then you would end up with secant squared minus tangent squared. Yep, that works. All right, number 4. Okay. All right, let's go to sines and cosines. What is cosecant? What is tangent? If you have sine on top and bottom, what happens? So then when you multiply, you have 1 over cosine squared x. 1 over cosine is secant. And secant squared minus 1 from the Pythagorean identities. Are these making sense as we go through? What about number 5? Okay. What does it mean if you have a parentheses squared? FOIL. So sine times sine would be sine squared x. Sine times cosine, sine x, cosine x. Cosine times sine is again sine x, cosine x. And cosine times cosine is cosine squared x. So this represents the first one, if I FOIL it. If you do the second one, sine times sine is sine squared. Sine times negative cosine. Negative cosine times sine. Negative cosine times negative cosine. Okay, so I didn't write the parentheses twice, but you guys know what I did right here. We can add in any order. What is sine squared plus cosine squared? That's 1 from the Pythagorean identity, that first Pythagorean identity. These are like terms, so that would be a 2 sine x cosine x. This one, sine squared plus cosine squared minus 2 sine x cosine x. So those drop and 1 plus 1 is 2. Do we need number 6? Alright, any obvious identities? Yeah. Look here, Pythagorean identities. 1 plus cotangent squared is cosecant squared. 1 plus tangent squared is. What is cosecant? What is secant? How do you divide fractions? So if you multiply those, 1 times cosine squared is cosine squared. Sine squared times 1 is sine squared. And what is cosine over sine? Huh? Uh-oh. We need number 7. Okay. So we have cosecant x minus 1 times cosecant x plus 1. So if you multiply, cosecant times cosecant would be plus cosecant x these cancel. We have cosecant squared x minus 1. Look at your Pythagorean identities. We have a 1 plus cotangent squared equals cosecant squared. So if you took that identity and subtracted your 1, cosecant squared minus 1 is cotangent squared. Not the only way. You could have got, if you got stuck at this point, you could always go to sines and cosines. Is that okay? Number 8. So again, multiple places to start with this one. The easiest option, how many terms are on the bottom? If there's only one term on the bottom, we can split it up and put each one over the denominator. What is 1 over tangent, or the reciprocal of tangent? What is tangent divided by tangent? Not necessarily the only place. You could have done more and maybe gotten to like cosine x plus sine x all divided by sine x or something like that. But number 9. So again, multiple places we can start. Easiest, if you recognize it, what is secant squared minus 1? Okay, not necessarily obvious from here, so if we go to sines and cosines, what is tangent? And then what happens?
That would have been a lot easier than how I did it.
You can also, if you go to sines and cosines at the beginning, change secant to 1 over cosine squared and then distribute your cosine.
I just distributed the length.
That works too. Do we need number 10? Okay. So we have cosine squared negative x plus cotangent squared negative x plus sine squared negative x. Alright, so this means we have the cosine of negative x and we square it. If you have cosine of a negative x, what do you do with that negative?
Drop it.
Yes, cosine's even, so it goes away, so that's just cosine of x squared or cosine squared x. This means we have cotangent of negative x squared. With cotangent, what do you do with the negative? Okay, so if I put it out in front, when you square a negative, it becomes sine of negative x. With sine, the negative comes out in front. But if you square negative, it becomes positive. What is cosine squared plus sine squared? And what is 1 plus cotangent squared? What if I told you I wanted you to add these together? Okay, so if my directions were to go ahead and add these things. Do we know what cotangent plus tangent equals?
No.
No. So what are your thoughts if I need to add them? Okay, we can rewrite like cotangent is 1 over tangent, but that doesn't necessarily make it easier. Let's do that. Let's go to sines and cosines. When in doubt, always go to cosines. So cotangent is cosine over sine. Make sure you put the theta on each. Also note, like if I use theta in the problem, please keep theta, don't change it to x because you like x better. Tangent is sine theta over cosine theta. Alright, I'm trying to add fractions. What do you need if you want to add fractions? So the first one has sine. What does it need? Do it on top and bottom. The second one has cosine. What does it need? Okay, what is cosine theta times cosine theta? And sine theta times sine theta is sine squared theta. What would we do now? Add, we can put them together. So maybe you could have done that in one step if you didn't show quite all this work, that's okay. When we add fractions, the denominator doesn't change, we just put them together.
Right, just go ahead and say 1.
Yes, sine squared plus cosine squared is 1. All right. What if I told you I didn't want fractions for our final answer? So we can't just say I'm going to multiply top by something because you'd have to have an equal sign where you could do it on each side, keep it balanced.
Decimal.
Is it? That's kind of the same as having a fraction. Since this is all one term, would this be equivalent if I did 1 over each?
Yeah.
If you multiply them, 1 times 1 is still 1, the bottom becomes sine theta cosine theta.
And then
What is 1 over sine? And what is 1 over cosine? Right. So we were able to add trig functions together, getting a common denominator on that one. All right, let's try another common denominator question.
Wait, why would it, how would it get sine and cosine to the top?
Well, we did, but then 1 over sine is the function cosecant.
Oh.
Other questions? I asked you to add 1 over 1 plus cosine x minus 1 over 1 minus cosine x.
It's got a plus and then make it square.
The right one's 1 over 1.
It's not a
Oh,
square.
it's not square, gosh dang it.
So if you want to add or subtract, what do we have to have? The first one has 1 plus cosine x. It needs second one has 1 minus cosine. It needs 1 plus cosine. Okay, so the top 1 times anything is the same thing. On the bottom, if you FOIL, 1 times 1 is 1. Minus cosine x and plus cosine x drop. Minus cosine squared x. Minus, this one we have 1 plus cosine x. When we distribute on the bottom, we get 1 minus cosine squared x. Okay, we want to subtract, so I'm going to make this a plus and distribute a negative. We have the same denominator, so we can put them together. Positive 1 and negative 1 cancel. Negative cosine plus negative cosine.
2 negative.
2 cosine. On the bottom, what is 1 minus cosine squared?
Sine
Sine.
squared.
No, because when you add together, the denominator doesn't change.
Oh, you're right, you're right. Cause it's
The first Pythagorean identity. Is everybody with me? Alright, I could leave my answer like this. What if I said I didn't want fractions in the final answer? What does it mean if I say sine squared?
That would just be 1 over.
Sine squared just means you have a sine times a sine, right?
So there's just be another one?
So we have a negative 2. I have a cosine over sine, which is cotangent. And then I'm left with this poor sine on the bottom, so this is just like a 1 over sine, which, okay, so kind of like the last one, we just separate this. I made it like a negative 2, cosine over sine, and a 1 over sine. Okay, just kind of showing you some different ways we can manipulate these.
What's it? Multiply, right, multiply by
Mhm. All right. Let's try something different. What if I told you to factor sine squared theta minus 1?
Difference of squares.
Difference of squares.
Okay. What's that go to?
That's sine minus 1 and sine plus 1.
Trying to that's what we're doing with all these algebra, getting common denominators, and multiplying and factoring. So all of our algebra works with these trig functions.
Are we gonna have an easy, are we gonna do a slip and slide?
Quadratic formula.
quadratic formula for sine and cosine.
Oh, there's
She's
more.
gonna give us this little slide right now. Yeah.
Kate,
There you
go.
Just for you.
Oh, I got
I
this.
forgot how to do this.
So what would I do?
Slip the slide, whatever you're doing.
So we have a sine squared x plus 3 sine x plus 2. So if we're trying to factor it, sine squared x is our variable. So each one gets a sine x. What multiplies to 2 and adds to 3?
2 and 1.
Okay, and then what do we have to do?
I divide by 2.
Why do we have that?
Two
I don't
sine
remember.
x plus.
You multiply the 2.
Yeah, you started out multiplying the 2 for your slip and slide, so at the end we have to divide it back. All right. So we practiced some strategies. What we are going to do now is talk about the reason we're doing all this is to start verifying some trig identities, some proofs. With these, yes,
Why'd you put a 2 at the end?
strategies. You don't necessarily have to write this all down, but these are the important things. Learn your fundamental identities and the equivalent forms. Know your reciprocals. 1 over sine is cosecant. If I make it 1 over sine squared, it is cosecant squared. The Pythagorean identities. We've seen that sine squared plus cosine squared equals 1 over and over again. But it doesn't always look like that. Sometimes it's 1 minus sine squared. So know that we can rearrange those formulas. We are going to be proving things are true. So I am actually going to give you an equation. Our strategy will be to put a box around the easier side and work with the more complex one. Okay, it's easier to take something complex and simplify it than it is to take something already simplified and try to turn it back into the nasty thing. We'll do that using factoring and algebraic techniques, and always keep your goal in mind. If I'm looking at my answer and I'm trying to get something with a sign in it, then I probably should go to sines and cosines. Okay, try to keep an idea of what you want.
You're saying we're proving it true, so like, is there a chance it's gonna be false?
No. All of these are true statements. You are going to prove that that's the case. So, because it is a proof, I'm giving you the answer. So it's like the problems you have been doing, except I'm telling you what it's equal to, and you're working until you get that answer. So it's kind of easier because you know when to stop. But that also means you know the answer, so you have to show me your work. You can't just say, oh yes, obviously, here's the answer, and box it in and pretend life is good. Because if I can't tell that you got there, I'm going to assume you just gave up and wrote the answer down. Alright, so you have to show me your justification on these. First problem. Secant of t times sine t plus cosine t equals 1 plus tangent t. There is really no right or wrong for these. It's just sometimes easier versus harder. We don't want to work this like a typical math equation where you add and subtract things to both sides. We want to box in one of the sides and leave it alone. So which side looks easier? The right. Okay, so I'm going to box that in. This is my answer. That means I'm not touching this again, but I am going to work with the other side until I get 1 plus tangent t. So, no obvious identities. We have a sine t plus cosine t, but they're not squared, so it's not the Pythagorean identity. What can you change secant t to? Okay. This is like sine t over 1, cosine t over 1. So if I distribute 1 over cosine times sine over, or sorry, times sine over 1 would give me a sine t for cosine t. Then multiply those. What is sine over cosine? What is cosine divided by cosine? Is that what we wanted? Okay, so here's what I want you to do. Box that in. So that way we can see we have 2 boxes. They match. We got the right answer. So it's just like yesterday, except you know what your answer should be. Yeah, free answer key.
What's the answer? What's the score?
Huh?
Is the answer key just a bunch of it?
Alright. Which side is easier?
The right.
Okay, so box it in. Cosecant squared. That's what my answer should be. I'm going to work until I get it. Any thoughts? What'd you
Change
say?
the stuff in the parentheses.
Okay. To what?
Secant squared thing.
Okay, tangent squared plus 1 is secant squared theta, if you recognize that Pythagorean identity. Now what should we do?
Change them both to, should we? Because it's, okay, change them both to over some 1 over 10.
Let's go sine and cosine.
Okay.
So cotangent would be cosine squared theta over sine squared theta. And what is secant?
The opposite.
1 over cosine squared. What happens when you multiply those? And we get 1 over sine squared theta, which is? That's what we wanted.
Could you have also changed it all to like sine and cosine?
Alright, let's do 1 or 2 more. Okay. Tangent squared s over secant squared s equals 1 plus cosine s times 1 minus cosine s.
I'm thinking the right side.
Yeah, it's kinda, neither one's great, is it? So you think the right side box that one in?
Yeah.
What can we do with the left? Tangent is sine squared s over cosine squared s. Secant is 1 over cosine squared s. How do you divide fractions? Those drop and we get sine squared s.
Then we put it into a,
Let's think about this.
what up?
Okay.
On the other side.
So here's the thing. We got this and it's simplified pretty nice. But it looks like everybody is kind of struggling, knowing what our answer is we're trying to get. How am I going to get there? So here's the option. Okay. If you realize you can get there by, we need to in factor
Take
form.
the sign out.
Oh, wait, 'cause
So
sine
sine squared is 1 minus cosine squared
Huh?
from that Pythagorean identity.
Oh, okay.
And then if you do a difference of squares, that factors into 1 plus cosine s. I could write. And 1 minus cosine S. So we ended up getting it. Awesome. Here's the other thing. If you get stuck, so let's say I'm working, I got to sine squared S and I just really had no idea how I could finish it. It is legal if you want to stop and box that in and say, okay, I'm stuck. I'm going to go back and I'm going to work the other side now. And what answer do you think I need to get when I work this side?
Sine squared S.
Sine squared S. So if you get stuck, you can go back and work them both and see if you can get them to the same point. What would you probably do over here?
Foil.
FOIL, so you get 1 minus cosine plus cosine,
Cosine squared of S.
and that turns into sine squared S. So when in doubt, don't just erase everything and assume you're wrong. Go work the other side and see if you can get it to
So
the
if
same
they're
point.
equal, then that would be your answer?
Yes.
Okay.
So if you got like one side to any certain point, you just have to get the other side to that point?
Yep. Okay, I'm going to stop here for today. We are by no means done with this section. We still have a long ways to go, lots of problems we're going to work. I am going to give you some problems to start. Tomorrow I will add to this list, but I am not collecting them yet, okay? So these won't be due until maybe Monday, see how things are going. Let's see, how much are we ready for?
Oh, wait, it's a textbook.
Alright. So I'm giving you several. Some of these are pretty short, like 1 or 2 steps. Some of them are longer.